Hello. Hello. 12:19 a.m. Central Time, Saturday morning now on May 17th, 2025. Just jumping on to say hi. Somebody asked that speak, talk. Okay, well, I'm speaking, but don't have much to say. I was just zooming in on the earthquake swarm activity. It's all small. Well, I mean, it's going up into the 3.0 range, but out on the West Coast, it's a bunch of zeros, ones, and twos, but we're starting to stack up. And whenever we start to stack up with a bunch of earthquakes, especially in Southern California, start to watch just to see if there's going to be any increase in magnitude. So something clearly there's a wave. This is the past 2 days worth of earthquakes, zero point 0.0 and greater. So clearly the wave is trying to make its way over to the east. And I mean, it's going over to the New Madrid seismic zone, but we haven't seen any big activity on the West Coast. No fives on land. Southern California's been relatively quiet, large earthquake wise. Supposedly out here off the coast, we've got the axial seamount eruption taking place. Hawaii swarming and erupting. Nobody's even covering it. It just erupted again this past week. Huge inside of the crater. I mean, it keeps going like every other week now. Like every 2 weeks, we're getting some huge eruption inside the crater of Kilauea, enough to where people aren't even talking about it because it just keeps happening and happening and happening. Be sure to check Two Pineapples and Doing Hawaii if you want to get the info on that. Look at the equidistant spacing of the fours and fives across the East Pacific, going all the way down to South Sandwich. And in the other direction, let's get all the smaller earthquakes out. Let's just look at the 5.0 and greater here. And look at the last, well, here's the last 6 days. And I mean, check it out. Last 6 days of 5.0 and greater in the East Pacific alone. Right? Do you see the equidistant spacing on this? Like, do you see how it goes? Set of three, set of three, and then we kind of branch out to the north this way, and we branch out to the south this way, and it's all the same sized earthquakes. Again, we're looking at 5.0 and greater. Here's 4.9 and greater. I mean, it didn't change anything, right? I mean, here's 4.8. All that does, 4.7 to 4.8. All that does is fill in the halfway points between the fives. Take it down another step, down to fours, just down to 4.0 and greater, and all that does is fill in the halfway points between the 4.7s. So whether we look at the fives or fours, we're looking at an equidistant spacing of the same size earthquakes. This doesn't happen all the time. That this amount of movement, look at that. So it's every plate boundary with equidistant spaced fives and greater across from Mexico all the way over to the Caribbean, down across the coast of South America, and Ecuador and Peru and Chile, and like I said, South Sandwich over here. Over here, we're out in the Pacific at Point Nemo. And then we take it back and look, equidistant spacing in the other direction. We'll back it up to show it to you. And then we follow the plate boundaries over, out, and over towards Europe, where our bigger earthquake is for the week, the 6.3 there, and our other 6.3 here on the antipode or opposite side of the planet. And then topping it all off, going around the outside edge of Antarctica. The only thing missing is an earthquake on the northwest side, or, well, up here, this big open stretch right there. If we filled that in with a single earthquake, it would be all the way around, guys. Right? Okay, so that's a fair amount of movement in 6 days' time, wouldn't you say? It all stems back to our deep earthquake activity and our solar activity. We had strong solar wind coronal hole activity, also an X-class flare with charged particles, which it has two different kind of earthquake effect. We've got the rapid, shallow earthquake effect when we get the strong solar wind, coronal holes, strong solar wind, not many charged particles, earthquake effect. And then we also get a different earthquake effect, which is the deep earthquake effect. And that happens after our charged particle storms. The electrical charge of all that goes to ground, basically, down to the core of the Earth. Then it comes back up with new deep earthquakes. The core of the Earth vibrates, basically, out like a bass speaker sending a seismic wave or seismic waves up towards the surface. And that's where we get our deep earthquakes that you see raised high off the planet here. So a bunch of deep earthquakes. Look, I got on a few days ago and told you guys. Not even a few. It was like last week. We started to see a whole bunch of new deep earthquakes and like a pincushion going across half the planet from Afghanistan all the way to South America. And that let us know something was getting ready to happen. As I told you, then it was like boom in Europe, 6.3, and then boom over here at Tonga, Antipode, 6.3, and then it's been the spread ever since. So that's a fair amount of movement. That is. And I think we're going to take the next step up. It sure looks like it because we have a new deep earthquake activity. We had the new X class flare 2 days ago. The charged particle storm should be basically, well, hold on. Ha, 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 ha. Hold on. Correction. If there was a charged particle storm that were to be released by an X class flare and it were to be coming towards Earth, then it would be arriving today. But as we know from looking at the Enlil and the everything, well, it showed nothing, absolutely nothing, just nothing leaving the sun at all. Bizarro world. I just dropped it after that. That was a couple days ago. We'll see, right? Like all of a sudden we start getting hammered with a bunch of new deep earthquakes. Yeah, I think we'll kind of have an answer on that. We'll know by tomorrow, right? So if we get to tomorrow and we don't have a whole bunch of new deep earthquakes or any big earthquake activity, then I might start to say, okay, maybe that solar flare or X class flare, not just a solar flare. I mean, an X. Usually you get some kind of release that comes on that. Okay, that being said, I mean, we could get one that doesn't, I suppose. Oddball out. Anything else worth mentioning? How about our smaller earthquake activity? We talked about this the other day, but going up here into Kansas, the 3.6 at the 1954 capped oil well, abandoned and whatever in 1954. That's where the 3.6 earthquake is. I have not looked up the 2.4, but I'm guessing there's going to be something similar at the location. I don't recall having to look up any earthquakes up here at North Kansas, so maybe we should go look that up. Also, the earthquake swarm in Oklahoma. That's the new addition. That stack of earthquakes there was not there before. I also want to say thank you to all my viewers who were concerned for my safety today. We had ourselves a tornado here in the St. Louis area that hit downtown St. Louis and caused major damage. 5 people are killed or more, and buildings collapsed. And I mean, it was a big deal, like pretty bad. Out here at my location, just west of St. Louis, we got about large marble to small ping pong size hail and one big gust of wind. But it was mainly hail where I was, so I got off pretty lucky actually with not getting any tornado activity. And then the hail itself, we didn't have any damage on the house. It was just small enough that it didn't cause damage, but man, it was loud. It took out a bunch of leaves on trees and branches, though. I'll tell you what, that was crazy. But St. Louis got creamed, man, creamed. Okay, so thank you to all my viewers for asking about my safety. And you guys know I'm on top of that kind of stuff, man. If it's going to be severe weather, I'm on top of it, just like the meteorologist would be at the local weather. Okay, let's go get the coordinates on this. 2.4. And by the way, this 2.4 in Kansas is the same size as the one that struck down there in Missouri yesterday. Let's go pull the coordinates. Agra. I guess that's agriculture, the Latin root word. Google Earth is working today for me so far, so that's pretty good. Let's see what's here. There may not be anything at the surface. I may have to go consult the good old handy dandy. Oh, what do we got going on here? That might be for farming. I would think that's for farming. Okay. We look for standout oil wells that'll be at the surface, and usually those are somewhat easily marked, or at least you can see them from this altitude. Usually be able to see an oil well out there in the field. It'll look like something like this, but you'll be able to see the shadow of a well or a jack or a pump at the location. Also tanks and pipelines and that kind of stuff. usually are connected to pumping operations, so they're pretty easy to see at this altitude. Don't confuse that with grain silos like this. Now, I said I'd probably have to go consult the oil well map for Kansas. So I'm just looking. Again, silos for grain. Again, the name of the location is Agra, so you would think it's agriculture. There's our state line up to the north. Anything else around the location worth mentioning? I mean, do we have like a large nuclear power plant or something at this large lake? Let's see, at this reservoir. Do you have any kind of power generation going on there? Or is it just for reservoir use? Okay, all right. It's a big enough body of water, you might be able to put a nuclear reactor on that thing. Okay. Let's go look it up. Kansas oil well map, Agra. Let's just see how far we are from Agra, first of all. Or a better way to say it is we are northeast of Phillipsburg. So Kansas oil and gas well map. There it is. I guess I should bookmark it, right? Oh, wait. Yeah, bookmark this. I'm using it enough now that I need to bookmark it. That's not good. Phillipsburg is where we're going to zoom in on. There's the lake, Wakanda Lake. Uh, hey, I get that right? Where am I zooming in on? Here we go. There's Phillipsburg. So let's go back really quick to the USGS map. Earthquake is northeast of Phillipsburg or just due north of Agra. So somewhere up here. Oh, well, I'll be darned. Look at what we got right here. What is this? Such land. Intent to drill by Cinco Exploration Company from 1982 and completed in 1983. Expired intent to drill. Okay, that's. Oh, wait, there's more. How did I even not see that? Okay, right here are several drill points. Not just one, there's several. Uh, why is this not loading? There we go. Gower 1, dry and abandoned, plugged and abandoned. Same company, Cinco Exploration, in the Wildcat oil field, or the field name is called Wildcat. Let's see. 1982 again. Permit date was 11/1982, and they plugged it in 12 of 1982. Let's see. We got to log into this thing. Okay, we don't want to do that. Let's go to the well record. How do they plug it? $20 sacks of concrete at $39.60, 20 sacks of concrete at $15.30, 100 sacks at $10.80, 40 sacks at $300, 10 sacks at the top. Ow. That's how you do it, boys. All right. Well, I think we've got our answer as to whether or not there's a nearby well. Let's just go make sure one more time. Let's go take a look and see how close we are just in general. There's Agra. The well I just clicked on is right here. And then there's more. There's 1, 2, 3 more here. And then there looks like there's another one down here. What's this? Miller Farms oil plugged abandoned. 1996, 96 and 97, just north of Agra as well. How far north of Agra are we going? Where's our USGS key down here in the lower left-hand corner? 1 to 4 miles north of Agra. Okay, and here's our key here. So 1, 2, 3, 4. So that's taking us up right next to these wells here, south of this circular one, and east, like right in there. Okay, got an answer. Another oil well from the 1980s and 1990s. That's what you got to do to go find it, guys. So this one was 1954, 1980s and 90s. Both are being hit as the wave is going across the plate. Let's go down to the south. We'll probably find active wells down in Oklahoma, where the swarm is. It's important to look them up, guys. You said you wanted to hear me talk. Well, looks like I go off on a tangent again. Oh, yeah, look at all these. So every little square on the ground like these is a different oil well. Remember what I told you? You could see the shadow of the jack of the pump, right? Well, there's one. There's tanks, pumps, pipeline, and there's our earthquake. Oh, and a set of high voltage power lines right next to it. God bless it. God bless it. Yeah, there. Look at that. Look how many there are. I mean, every single one of these is a different drill point. So you start to see they go right up to the river. Wait, hold on. Really? Ha! The Cimarron River. Don't mean to laugh at that. Like, that's actually, when it floods, like, oh, don't worry about it. It's going down deep in the earth, Dutch. Doesn't affect the groundwater at all. Why do you have protective berms around it then? Okay. All right, see them? All these little squares? Every one of them is a different drill point. Not to be confused with the greater farming squares, right? That's like a farmer's acre, if you want to call it that. More than an acre. I mean, each one of these sites is multiple acres. But you get the idea for how many drill points there are. It just keeps going and going and going and going and going. I'm just randomly zooming in on different spots. That's Oklahoma. Okay. The rest of the earthquakes in Oklahoma and Texas are all at drill points as well. I mean, every single one of them's at a drill point. I'm not going to waste our time. Over to the east on the New Madrid seismic zone, that one is not on a drill point, and that is next to the power plant there. They got a large electrical generation power plant in the town of New Madrid, or right outside of it. But man, look at this line of earthquakes out at west. Look at it, guys. Look at it. Even the untrained eye should be able to see we have like a line of earthquakes coming out of California, kind of going down towards Arizona and South Utah. You see that? Right? And then you see along the coast, it's all filled up all the way down, and we're stacking with earthquakes now. So the whole West Coast is in motion right now. And look where they both point back to. If you were to trace this line of earthquakes back up to the northwest, right? And trace this line of earthquakes back up to the northwest. And where do they both point? Juan de Fuca, axial seamount. And then up here, same thing. Trace the earthquakes. Where do they go? Make a line of earthquakes. Where do they go? They go back up to the northwest. Look at the last few days. So the plate is in motion. It doesn't do this every week like this. I mean, every week we'll see earthquakes go across the plate, but when you start seeing it stack up like this across the board, it means something's getting ready to break off the coast. Usually. So usually it means a big earthquake along the west coast. When you start to see the plate move, you also then watch for the rest of the plate to move along side of the West Coast breaking, then you look for the rest of the craton to start shifting on a greater level than where we are now. So let's just say we get a, let's say, mid-range 5 that strikes in Southern California, down LA, let's say. I would then expect the next magnitude up to go across the entire plate, which would mean another 5 in Texas, and that's rare. And then 4.6 in Oklahoma, 3.5 in the Midwest and the New Madrid seismic zone, Illinois, going into Missouri. And we're talking about taking the next step up. Don't forget, there was the 4.1 that happened just a few days back down in Tennessee, down in the southeast, down here. So over the last week, let's look at 0.0 and greater, turn off all the numbers, and just look at where they hit. So 0.0 and greater shows it's like a big letter P out on the West Coast, right? But really, if you look at it close, you'll see it's 2 sets of diagonal lined earthquakes going across the edge of the craton. And then it goes over to Texas, and boom, we go across the edge of the craton and the interior side of the craton and the exterior side of the craton. So we're talking the middle of the craton, that's the red arrow. And then right on the inside of it, Kansas. And right on the outside of it, outside Texas, southern Texas. And on the east side of it, all the way over to Tennessee. So I'd look back to the west, but then you got to remember there's the eruption happening off the coast. There's probably a whole bunch of earthquakes striking out there, and it's hush hush. And I mean like hush hush as in don't report it. Sooner or later, they're going to have to turn it back on, guys. Are we really to believe all the earthquakes 0.0 and greater stopped off the coast at the volcano while you're telling us that there's warning signs that the volcano is going to erupt? Like, which is it? Are there a bunch of small earthquakes striking out here being picked up by all those sensors that you put out there? Why not report them to the public? You know why, right? There's already thousands of earthquakes striking there every day, and it would alarm the public. So what they're going to do is they're going to wait till it physically starts erupting down there in the ocean. Then they're going to turn the feed on for a little bit. That's what they're going to do. These guys, man, I'm telling you. But here, to their credit, they're trying to save the cost of real estate. We've got a bunch of geeks and nerds trying to save the cost of real estate by turning off the feed. And I could, quite frankly, I think they might be doing the right thing. I like to complain about it, and I like to throw a big old fit about it. But if I was in their shoes, I'd probably do the same thing. Because man, people are stupid as they're freaking being assholes lately, and everybody's on the edge. Anyways, last thing we need is that. Plus, everybody freaks out. Look at the mainstream media. Look what they did. It's not people on YouTube this time, guys. It's not. You cannot blame us this time. No. This time it's CNN, bottom of the barrel. They've now become the new YouTubers, basically, like fishing for views because they're hurting so hard. So they have to get the shock value up on CNN and the other places worse than they used to be, which was already bad. And so we've got a headline that read something like this. Listen to this. I saw it on a video on X. Somebody made a video and said, look, the mainstream media said imminent eruption, which, okay, that's true. Going to blow its top out off the coast. I'm paraphrasing here, but the words blow its top with 10,000 earthquakes accompanying it. That's the headline scrolling by at the bottom of CNN. I'm like, oh my God. They are worse than your worst YouTuber guys. I'm not joking. Mainstream media sucks. And that's why, because they're looking for views and fear porn and trying to make money way worse. Because with a YouTuber or somebody like me, you can hold us accountable. You can come into our chat room and tell us off. You can make posts and actually affect us. But with them, it's like you can post all day long and complain all you want, and they still get paid because they have advertisers working out deals that last for years, that pay billions. So they get paid regardless. And the more fear that they generate, guess what? The more watching that they can report to their advertisers to get more money. Long story short, mainstream media dropped the ball with this axial seamount eruption thing, blow its top. Me spending like 2 days responding to comments. No, it's not gonna blow its top, you pieces of shit. Shut up and fucking CNN. All right. Now, blow its top is a relative term too, because technically the top of this thing, here, let me show. Hold on. Look, if I did this, everybody would bust my balls. Okay? So here we are. We're off the west coast of the United States. And here is the axial seamount. Here, let's turn on our volcanoes and place marks and all that good stuff. See, it says axial seamount right here. But really, it's part of the cleft segment, coaxial seamount, Cobb segment. See all these volcanoes out here? See these chains and lines of volcanoes? Some of them are cone-like. You would think of them like spatter cones they build up over time. And then others are more broad, more like a volcanic field. And then in the middle of this large volcanic field, you see how many there are here? This thing's constantly erupting, guys. I stand by it. This thing is constantly erupting. They don't talk about it because, again, real estate prices on the West Coast. You start talking about eruptions on the West Coast, people don't understand. You have like 10 million per year. Okay. Maybe 10 million is okay. That's overkill. You have a few thousand eruptions per year, adding up to tens of millions of eruptions over a long period of time. And look how many there are, right? You see all the craters. So this is the axial seamount, the bigger feature here. Let's measure it across and get our mileage on this thing. 2 miles across total. What? No, I'm sorry, 1.8 at the center. Okay, let's just say 2 miles. 2 miles at the center. And to put that in perspective, let's go out to Hawaii and go to the center of Kilauea, let's say, and look across its crater that we normally look at, either the center of the crater or the whole thing, because this is really, I mean, we got the lava flows and this thing collapsed. So, see, it's 2.5 miles wide. Now, if you just want to go with the interior crater, the one that's currently filling, we're looking at 1.2 to 1.3. So somewhere in the range of about the size of Kilauea, which Kilauea is nothing in comparison to Mauna Loa, for instance. But Kilauea, with its effusive flows and lava flows, we can go back over here, and it's kind of, I would say it's an underwater Kilauea along a fracture zone that's spread out, just in size. So is it end of the world? No. Now, this thing doesn't blow its top. Big blasts don't come from this kind of volcano, as evidenced by all the other previous eruptions all around it for the past however long the entire frickin' plate was here. By the way, this has been going on, apparently, for a very long time. Long enough that there's chains of volcanoes that are ancient going back and forth in lines all the way to the north. Now, you see they're all kind of going in the same direction, though. Northwest to southeast, pointing in this way. And then we go down here, and they go the other direction. And then they start going the same direction again here. Right? So these volcanoes are following the direction of the fracture zone. And that's why the axial seamount is going in this direction. Is it going to blow its top? Well, out the top of this thing should come some lava, which it'll make it that underwater lava set. There'll also be maybe even pumice that comes up to the surface. Now, the depth on this is hold on, 6,000? No, 5,000. 5,100 feet deep. So we may get something that comes up on that's actual some pumice that floats to the surface. Now, I want to take everybody back in time a few years. And I'll have to go find the video. I don't have it readily available. I'm just remembering it right now. Right here along the Gorda Escarpment, there was some kind of undersea eruption that actually took place, and there was seismic with it but a plume of something came up from that depth up to the surface and quickly shot out into the sky. And it was on weather satellite, but no seismic was reported by the professionals. No talk of it, nothing. I was the only person to even capture it. You guys may remember it. It was a big puff that came out of the ocean and went straight up. Somebody tried to say it was a ship doing it. A ship. Now, I have seen those giant weather modification plumes done by the ships out in the ocean out here in the Pacific. It wasn't like that. It was a puff that came out of the ocean. We were able to zoom in on it pretty close with the weather satellite to get a good shot of it. It was definitely coming. Actually, it was more out here. It was out here where all these undersea mounts are. So you see how many there are. There are like it's a huge stack of 1,000 or more, not many thousands of volcanoes just right there alone. But it came out right in here, and it's just I was the only person that even caught it. Would it show up on seismic? Oh yeah, yeah, it should have showed up on seismic for sure. And now again, people aren't going to report it. Professionals don't report it. Everybody ignores it. If it's on a private seismograph, who's even going to know? Like somebody's going to make a video and be like, "Oh, something strange showed on my seismograph today." And even if they did, would you see it? Okay. That being said, that's your update. It's Friday night, Saturday morning. I guess we're going to jam some more now. You guys got to hear my voice. You got a little mini update. We're going to look for some larger earthquake activity this week that goes the next step up from where we were this past week. So this past week we were at 6.5 or 6.3. So I think we're going to take the full next step up. That means we'll be talking about sevens this week. And then we get into our basic earthquake forecasting. When you want to know where to look for the large earthquake activity, you start looking between your sets of deep earthquakes. And then that kind of lets us know where we're going to watch. We're going to watch West Pacific again. Look, 3 sets of deeps right there. We got one over at Afghanistan. This pretty much means Indonesia, Philippines, but not just anywhere in Indonesia. I mean, we could nail it down if we want to get the forecast out. We could just go ahead and zoom in on the areas. Look, there's 3 sets of earthquakes that are kind of focused in on the spot to watch. S-shaped bend in the plate. This goes as far south as East Timor and as far north as Philippines. In the center of all of it, the hot mess. That's where we watch. North side, we go up into Japan. And we have a deep earthquake at Japan. Ooh, Tokyo. Tokyo is going to get hit this week. Now, I think Tokyo will be in the 6 range, so that should be okay. So I'm thinking the 7 will be right down here, and the 6 will be up here, Tokyo. What else? Let's take a look and see what's going on down in New Zealand. Anything worth mentioning? South of New Zealand. We have to watch south of New Zealand. I mean, it's pretty obvious, right? We got an X there and there's nothing on it all week. So just south of New Zealand, I'd watch La Esperance Rock. Am I saying that right? La Esperance. Whatever. La Esperance Rock, south of New Zealand, south tip, going down to the X, and that's a pretty large stretch to watch, but I sure hope it strikes out in the ocean so nobody gets injured. West Coast USA, watch down in Southern California, LA Basin, 5.5. And out off the coast with the axial seamount, watch for the professionals to turn on the feed.